Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir. Yes, sir.
Okay. Thank you. And the first thing normally I
Yes,
put
sir. Yes, sir.
in the first slide I put the CC0. That means Creative Commons zero license. That means if you find my presentation useful, you can use it. And if you are even more aggressive, you can just remove my name and put your name. I don't have any objection because I am a staunch supporter of open access to information, open source software, open standards, and open courseware. That is, nowadays it is called open e-learning, this OERs resources. So that is the case. Now I go further down. Okay. Now what I am going to talk is about data I'll give, and also I will talk a little about big data. Though I think big data analytics, not exactly our purview. Then open data, of course, as an open source, open access to information advocacy. I also support data should be open. Then research data management. Actually, data management has two aspects. One is the government data, okay. Another is the research data. I just briefly tell you the government data is also important. The reason is for better governance, the data, the decisions by the planners should be supported by the actual data. Okay, that's why I have been advocating smart cities. I found smart cities means road widening, then giving internet connectivity and all that. I think that's not, at least my view of smart cities. My view of smart cities is you collect the data from various departments of the governance, like how many vehicles are being registered, how many traffic jams are happening, how many accidents are happening, okay, what are the bottlenecks in the traffic, like that, or how much waste is being generated, then what is the waste management techniques in place, how many recycling plants are there, down another 5-10 years, how many more are required. Like that, I feel the data should support a powerful, should able to create a powerful decision support system, not that widening the roads and all that. That's not my view of smart cities. Anyhow, but here I am going to concentrate more on the research data management, which is, of course, we know that universities, research labs, even private research labs, all these generate a lot of data. Okay, so how do we manage this research data? Then what is exactly the data librarian does? Because nowadays, I think another group of librarians are emerging called the data librarian. When I was in Brisbane, Australia, already they have in place some data librarians to handle the research data that is being generated by the university. Okay. Oh, why? Okay. Data. Now, we have many kinds of data. One is experimental data from various laboratories and other things, and from medical hospitals and medical research associations, we have clinical data, and we have observational data. Of course, various observations, whether it is through telescopes or even part of the survey research. You know, we do make observational survey research. We send questionnaires and get the data. So basically, there are many ways we have data. And also these data, whether it is clinical or experimental or observational, they can take the form of numerical data or textual data. You know, one of the biggest challenges, actually, that is where AI came into picture. On internet, we have a lot of textual data, but unfortunately, the data is not structured as in the case of database management systems. So one of the biggest challenges in data mining, text mining, is how to make structured data out of unstructured data, because humans don't require directly they can comprehend and understand textual data, but computers cannot understand continuous text. But nowadays, I think we are overcoming, though not fully matured. I am sure down another 5 years, a lot of maturity will take place. Then we have visual data. Visual data could be satellite data, or that from images, videos. For example, remote sensing people use lot of satellite data. Okay, from where they try to uh, predict. Okay, this much forestation is lost, or you have the satellite data about urban planning or weather and all these places. So it could be in digital or physical format. But we know that computers handle mostly digital data. Probably we have to resort to digitizing or retro converting the older data into the newer format. So I have told that mostly in the database management systems, which have been around for the last 50 years, we have been using, we know how to handle structured data. For example, whether it is salary or our bibliographic data, Mark XML data or Mark XML. And we have, of course, various CCF, Unimark, so many marks, which usually when I teach the mark cataloging, my BP raises. Actually, the mercury touches the ceiling because I am dead against Mark 21 or CCF and all. Badly designed they are. I guided some 2 students only to strip down the Mark 21 and Unimark. How ignorant these people are. Either cataloging, they do not know either cataloging or database systems. They introduce a lot of redundancy in data. That is another topic. Anyhow, then we have semi-structured data in emails. Emails, we can find out some kind of a structure in the sense who has written, to whom it was written, what is the subject note and other things. Actual text data is unstructured because textual data, that is. And totally unstructured is, of course, video data, audio data, and much of the data on internet. Then who are the stakeholders? When we talk about I feel this is data is a multidisciplinary area. Okay, so capturing the data, that is collecting the data, putting in formats and making it structured data, using standards for file formats or anything for interoperability and discovery. We know that metadata is a powerful discovery tool. That's why Google generates a lot of noise because it handles unstructured data, Google search engines. Okay, but we know that bibliographic databases like Koha and others, they give better search features like I want books by Ranganathan or on Ranganathan. So we know that by Ranganathan means if the author field has Ranganathan, retrieve it. That kind of nuances in search is not possible on Google. With all its so-called bells and whistles, the most powerful search engine became almost the de facto search engine. But we know that you cannot do many things, which even bibliographic databases, whether it is Sol or Evergreen or Koha does. And we know that if you follow open standards, it ensures long-term preservation and interoperability. That means, for example, tomorrow I found GIF is no more being used, but I want to migrate the image to another format. But GIF is a proprietary format. So you cannot, because usually these image and audio formats are nothing but compression algorithms. So unless you know the compression algorithm, you cannot decompress it. Okay, but again, if it is, for example, your Word, MS Word, for example, MS Word is the proprietary. Of course, they say docx is XML based, and there are various politics behind it. I don't want to go into that. Why docx is introduced instead of ODP and ODT, which are approved by ISO, but of course now MS also managed to get it by ISO. That's a different political scenario. Okay, so migration of the data. For example, if I have, I remember one of my friends has, his thesis was in KaiWriter, but now he cannot open those files because KaiWriter is not available anywhere in the on the systems. Okay, that is the reason open standards are very, very essential uh, to uh, store and disseminate the information. Then filtering and weeding out what is unwanted. This is a highly subjective. Weeding out also is, I know that our statistician, bibliometricians or scientometricians, they say life of a cycle, half-life of an article. These are very difficult, highly subjective. Whatever you find today is useless. Maybe down 10 years, all of a sudden you realize, oh, I should not have deleted that. But this is not the case with humanities. Still, I think people keep on debating about what Socrates or Plato told. But in sciences, it is a tricky affair. I know, I think many of your libraries may be having DSpace and WordStar books. Definitely, I think they should be weeded out. But again, putting them in electronic form, because print form takes a lot of storage area, minimizes the severity of the problem. Then, so data curation, this is, I think, the much of it is being done by the library and information science. People, for example, if you have a tabular data, you can find out what are the missing values in some fields, whether there are any duplicate records. Then how to see, you collected some survey. Some are in feet, some are in meters, or some are in pounds, some are in kgs. How do we normalize the data? There are, of course, powerful tools like OpenRefine. In fact, we used OpenRefine when we conducted international workshops for data curation with co-data people. Okay. Then technology for big data, because we know that the big data is in petabytes. Okay. I think only our computers are talking about terabytes. But by having clusters of computers, you can handle petabytes or exabytes. How do we handle them? That is the technology, guys. There are some Hadoop ecosystems, NoSQL databases, so many technology tools. I will briefly touch upon them, but I would not go much into that, though I dabbled with some of these tools. Then data analytics, where the statisticians come into picture. They have predictive, that is descriptive. I think much of statistics we use are descriptive analytics. You are given a big table and try to find out what is the co-occurrence, correlation between two factors or various other things. But I think here more important is what is predictive and what is prescriptive analytics. And finally, the data is being generated by domain experts and consumed by domain experts. All the three above professionals, whether it is librarians or the technology people or statisticians, they only play a second fiddle to the domain experts. I know that often I hear that the technology guys can do everything. Oh, if that is the case, I think we can close down every subject and give it to the software guys. But basically, for example, I know a lot of weather forecasting guys, meteorology guys. They develop the numerical models of predicting long range or short range or medium range weather forecasting. And they use, I think, of all the scientific communities, they generate the biggest data. That's why government of India long back bought supercomputers. I think they are the only guys who were having. Of course, now they are outdated computers with Cray XMP systems in Delhi. Okay. But finally, what I mean to say is it is the domain experts. For example, if you want to develop a library automation software, coding people do only translating librarians' ideas and theories into some programming language, but not that they know the intricacies and nuances of library management. Okay, that is, I think, the domain of the library science guys. Okay, so big data. What we consider big data is whatever that cannot be handled by traditional processing, data processing, like database systems. We know that database systems, RDBMS, like MySQL or Postgres or MS SQL, or Oracle. They cannot scale. Okay, they can scale to a certain extent. Okay, maybe Oracle can scale better than the rest, but again, if it goes into petabytes or exabytes, they cannot scale. So what are the sources? Who generate these? We know that laboratories, universities, and industrial R&Ds also. Okay, and the data from research is this one, from projects, surveys, thesis, and dissertations. And we have streaming data. We know satellite data and data by various sensors and CCTV cameras and all that. Because once I was addressing the DGP, the Director Generals of Police in Karnataka. So they wanted to have from the CCTV cameras about the accidents and other things. How do you handle that? So you get a lot of data from CCTV cameras. Imagine from Bangalore, maybe there are a few thousands of CCTVs, and how do you process the data? Or satellite data, that is also, we know that. I mean, the entire orbit is polluted with a lot of satellites and sensors. Okay, sensors, that is, it could be laboratory equipment or medical equipment. All these generate huge data. In fact, equipment generate more data than what humans can collect in tabular form. Okay, so that's why they say big V's of the big data. That is, volume is terabytes or zettabytes, and variety, structured and unstructured, you have velocity. Okay, the kind of information data that is being generated every minute is enormous. There are others also like veracity. What is the validity of the data? Because we know that there are humans are biased, subjective. A lot of noise will come and abnormality also will be there. Because once I visited in Pune, that radio astrophysics, that is from radio telescopes, they collect a lot of cosmic rays, and they have to filter a lot of noise and generate the pictures of nebulae. Okay, so how to remove the noise? Okay, that is anyhow the domain experts there. And validity, trustworthiness, normally it is subjective. Whatever I want to trust, I trust. Otherwise, I don't trust. For example, if somebody talks about bad things about my own close friend, I don't trust him. Or my favorite political party, something negative comes, no, I don't believe this. Okay. Then volatility, obsolescence of data is also, when so much data is being generated, handling obsolescence is also a big thing. Just statistics, Facebook generates about 4 petabytes every day, and YouTube has 500 hours of data every minute. Then you can imagine what kind of clusters of computers they must be having. They say that Yahoo search engine uses 4,500 cluster of computers. Okay, I mean 4,500 computers as a cluster. Okay, Google handles about 20 petabytes, blah blah blah. Okay, so that means we know that big data approach. Okay, that's why to sort 10 TB of data. Say for example, I have a citizen list of Oliver or something like that, which comes to about 10 TB. Then it takes about 2.5. But if you have a 100 node cluster, it can be done in 35 minutes. Okay, there is horizontal scaling and vertical scaling. Briefly, I tell you, good old days, we use, if I have a server, I used to keep increasing the storage and also the main memory. But nowadays, what they do, they keep on adding more and more computers to a cluster. This is horizontal scaling. Okay. Now also are coming NoSQL databases. Okay, there are many, and for example, there are key value and column-based, document-based graph. Actually, we experimented with the graph databases because graph databases talks about relations. For example, about again ontologies. See, what is the difference between a thesaurus and an ontology? We know that I think when I was a student, thesauri were very, very common. We have mesh thesaurus or inspect thesaurus and all that, or FAO, agrawalk is there, agricultural vocabulary. And what we do is we take a word, whether it is used and used for something else, whether it is a standard word or you have to use another, use so and so word, not this word. Then we have BTs, NTs, like that. So unfortunately, this is typically are related words. But in this, what we do is we mention for a certain word, these are the narrower terms. But we know as library science people, narrower terms are generated out of two things. One is genus species relation, that is rice. You have, for example, Sona Masuri or Basmati. This is genus species. Or rice, parts of a rice. Okay, whether it has a kernel, blah blah blah, like that. Okay, so that means whole part relation, but we don't make it explicit. We say just these are entities, and we combine all kinds of entities which are generated irrespective of whole part or genus species relation and dump them together as entities. But in ontologies, we tell them what exactly the relation between these two words. Some word is there, artificial intelligence, natural language processing. Okay, the relation is more a genus species relation, not a whole part relation. And we have related terms. Related terms, artists we never bothered. For example, if you have gold, ornaments is there, gold mining is there, okay, then gold processing, so many things are there, I think. So we don't mention the relation. That is, I think, the task is taken care of by ontologies. If you have relations, we can build inference engines and get better information out of the data. And also, just as we say identification, persistent identifiers. We have ISBN, ISSN as persistent identifiers. But nowadays, for authors also, we have ORCID identifiers. Subject terms also, we have identifiers. If you have numerical IDs assigned to every term, the advantage is we can build cross-lingual ontologies, okay, irrespective of the language. Okay, now slowly we are realizing English is the dominant, but not the only language in the world. We do accept as librarians 80% of the scientific literature is in English. But again, we have to also encourage other and information in other languages and other thesauri, okay, like that. So we experimented with graph-based, and actually I always ask the students, because these databases need not have the, we know in a typical bibliographic database, every record will have more or less the same fields. But in the key value and column-based ones, that's not the case. Actually, using relational databases for bibliographic data is a ridiculous affair. One has to do a lot of harakiri and acrobatics to handle the bibliography, because repeatability concept is not there, subfield concept is not there. There are many things which are required are not there in the relational database, but people has to do really acrobatics to manage it. But in these models, they scale also better, and each record may not have similar set of fields. Anyhow, that is, I don't go much into this. Okay, Hadoop is the backend, and of course, many people use Hadoop ecosystem for handling big data. But anyhow, we are not touching big data much. Okay, this is a big suite of software. You have so many, and I think obviously some Indians are involved. You can see Ambari is there, which is I think for this one, and Mahout is there. These are, I think, all the Indian words. These are some of them. Anyhow, I don't. Okay, they use HBase as a NoSQL database. This I don't go much into that. Apache Spark and all that. Okay, now coming to the statisticians. So if you want, for example, I am sure many of you must be pursuing your PhD, and though personally I try to discourage, but I think about 90% of our theses are based on survey research. Some are about 10% are based on citation studies. Only I appeal to you, there should be fundamental research also, because this sounds a bit repetitive, okay? But in any case, if you are going for using statistics for your thesis work, there are open source software called R and R Studio. R and R Studio, the difference is one is a graphical environment, R Studio, but you can use R. And there are some plugins for citation studies in R. Okay, MATLAB is commercial; it's a powerful one, but I tell you, don't go for SPSS or MATLAB, which may really pinch your pocket. I mean, or the organization's pocket, or otherwise you have to resort to some plagiarism, the piracy, and all those things, illegal activities. Okay, shall I tell you? In the last 20, 25, 20 years or 25 also, I have stopped using commercial software. Okay. I know even when I was young, I used to get excited breaking the key and find on the internet some spurious sites that give some codes. I mean, the key and I broke the. Now I think even if somebody gives it me free also, I say, no, I don't want it. I remember Oracle country manager once approached me. If you teach Oracle, we will give you multi-user license and Linux-based free, completely free. Of course, not that they love academicians or faculty. They think if the students are taught Oracle, wherever this guy goes, he demands Oracle should be bought. Okay. There is nothing called philanthropy in business. Okay, that you make it. I know clearly. Okay, much of the research also is completely bribed. Okay, don't think that scientists and professors are not bribed in publishing research results. One fellow says onion is harmful. Another fellow says Coca-Cola is harmful. I think they wait for the Coca-Cola guys to come and bribe them. Okay, so after all, it's a human being. So, okay, some are good, some are bad people. So I strongly advise you, if you are using statistical analysis, go for R and R Studio. That is a free software, and you can use either in Windows or Linux. Of course, I don't use Windows. Okay, I think Windows 95 was the last for me to use. After that, I never touched it. Okay, now descriptive analytics. That is what normally we do with statistics. I think that is the way statistics is taught to us in master's course. Purpose is to summarize what happened. That is, you collect the data and try to find out whether the information, as big data is not suitable for human consumption. We know that, large data. So descriptive analytics allows you to condense the big data into smaller or more useful nuggets of information. For example, if you are presenting your data, you cannot present the data in raw form. So if you put it in either bar chart or pie chart, it would convey better. Okay, practically you are summarizing. You are not showing the entire raw data. Okay, you are summarizing the data. Even tables also may take some time for the other person to get the idea of what the table is about. But if it is a smaller, of course, table is much more descriptive. But otherwise, we try to put it in graphics. But even to arrive at the graphics also, we might have used a lot of statistical analysis. So predictive analysis, that is, I have the data I want to predict. For example, if I have the data about some terrorist attacks, bombing and or other things, then I try to predict where it would likely be bombed next time by a terrorist. But don't think only terrorists use terrorism. In many countries, even governments also resort to terrorism, which is called state terrorism. Okay, so how do you predict? Okay, how do you? Okay, is there any pattern in their attacks? Okay, or anything, for example, any experiment, whether there is any pattern. Patterns are very, very important. I tell you, we use pattern recognition even for grammar, even to identify some tree or plant. All these we use patterns. Okay. So how do we predict? So if we have that, we try to see the statistical data and try to analyze the data and try to predict what is going to happen. But again, remember, These are based on probabilistic models. Probability is probable, it is possible, it is probable, it may happen, it may not happen. Okay, because there are so many factors in predicting the future, because a lot of parameters come into picture. That's why in philosophy, when we talk about theory of causation, we say that single cause is difficult to predict. I mean, many people believe. If you ask me with my philosophy background whether I would accept Big Bang theory, everybody says there was a big out of that universe. Hey, single cause won't happen. Okay, it requires a lot of other things to uh, parameters to be satisfied before something to happen. For example, we have a typical example. I want to create fire. That means in the atmosphere there should be oxygen. If there is no oxygen, I cannot light fire. And there should be some inflammable material and somebody to strike, some agent to be there. So many are to be satisfied. And so it's a multi-cause. Okay, single cause I don't accept. Once I confronted with an astronomer, do you really believe that the Big Bang theory is right? After all, it's a speculation. Don't think that science is based on only facts. There is a lot of speculation also. Okay, so so I can I can prove what is not science in science. And what is so great about science? I used to feel, I think in 19th century, because of bombs, so physics guys became popular, whether it is Einstein or Abdul Kalam and all these guys, 20th century especially. But I feel I'm a pacifist. Okay, I feel even that science bug hit Professor Ranganathan. He tried to prove librarianship is science, and he introduced the spiral of scientific method and tried to prove science. Hey, there is no big deal in science. Okay, in fact, I do accept much of the developments in the society are the outcome of a scientific contribution, but at the same time, much of the research is out of the defense, so-called defense. Basically, every country's dream is to kill its neighbors. Okay, I mean, I may sound talking extreme, but that is reality. Internet. What is the origin of internet? First, it was DARPANET, then became academic network ARPANET, then it became internet. Your satellite technology, okay, is the countries, this one, what is the movement of the enemies, armies, and other things. Okay, your Sas Bahu kind of TV serials are a byproduct of that. But main interest that nuclear physics directly related to this one. That's why I see now then another war broke. These are, of course, I don't want to go into that. But on the whole, I think I am a pacifist. I am dead against any wars. Okay, there is nothing called, nothing can justify a war. Then predictive analytics, so we have to forecast. So for that, we use probabilistic models. Then prescriptive. So if we can predict something, then what are the prescriptive measures? So whether I can simulate these measures to mitigate the prediction or something happening unwanted. That is what exactly the predictive analytics come into picture. Now open data. Okay, this is, I think, my favorite area. And as I told you, we have government data and research data. Okay, then reusability is the main scheme. Okay, why we are talking about data? It should be reusable. Why open data means if you have done experiment, I can use the results rather than I am doing the experiment, the same experiment again, which saves money, okay, and effort. And readily it can speed up my research work because I use the others' data. Okay. So reusability is the most important thing. I always say the entire evolution of mankind has been possible with reusability. Okay. First thing is the greatest advantage the humans had is language. So they can communicate whatever. I burnt my fingers putting in fire. Then I will tell my neighbors, hey, don't touch fire. Okay. So that is reusable. So language definitely allowed passing on information from one generation to the other generation. But again, sometimes we know that oral traditions disappear. Okay. Of course, in good old days, people never trusted writing. They think oral tradition is better. That was the case with, remember, because I read a lot of history, remember, all the literature in every language in the world, the first form of literature is poetry. Why poetry? It is easier to remember. Prose is difficult to remember. So if it is, that's why we teach the children also first rhymes so that they can by heart easily. So whether it is Vedas or Tripitakas or of Buddhism or Homeric poems, okay, all these are in the form of poetry. So that oral tradition for a long time until the invention of scripts, we had to rely on passing the information orally. And when scripts came into popularity, of course, we know that Tigris and the Euphrates of Sumerians of the present Iraq, the clay tablets, okay, cuneiform, of course, there also the historians believe that on clay tablets you have to press with something. That's why the characters are squarish, like a sharp corners, not roundish, which is the case with many present language. The tools of writing makes the shape of the characters. Okay. Anyhow, librarians definitely played an organized and institutionalized role in reusability by preserving and disseminating knowledge. So I think that is one of the greatest jobs the librarians did to the mankind. Without libraries and librarians, okay, even we know that even Aristotle and others also were librarians. But that time, a special group was not there. Later, when a lot of literature emerged, we required specific skills, highly specialized skills, and developed a group of people who can handle large amounts of scripted data, that is written data. Okay. So now they say that in science, if you want to, nowadays, of course, you know that everybody is talking about open science and open research. Actually, I prefer openness because you know that only people with wrong things in mind try to keep their research secretive. Okay, it could be either, say, for example, I found a wonderful formula for bombs. Okay, they keep it secretive. Okay, because the others should not use bombs, so that only I can kill. Okay, or otherwise, another thing is profit. Profit also makes things secretive. That is only I should yarn, others should not yarn, so I should not reveal these techniques. So anyhow, that's why we say that, for example, if the data is not open and hidden in some dungeons of the archives, we call it a dark data. So in case of government too, a lot of unpublished data is nothing but, there may not be classified data, but they don't publish it because we are not quite organized. Okay, why data is not published? Okay, we know that even the modern times, when internet, storage tools and media are available, why we don't publish? One is publisher's point of view, lack of space. Usually, of course, until recently, publishers were only accepting your final publication, that is your paper. Okay, but nowadays some publishers are insisting, no, you should give the data also for verification, because if I verify the data, probably I can doubly sure about the paper and its claims. Okay, and now of course you cannot say no lack of space, because on internet and all that we can store petabytes of information. Okay, And another thing is author's point of view. Author might have overlooked some of the data. Actually, building a data repository is very difficult because many authors don't share their data. One is they are not sure of their own data. Another is they feel, oh, it is my baby. I should not give it to the others. I tell you one simple instance. We were doing the European project on agricultural data, and one of the partners is a nuclear physics lab in Italy, okay, in Sicily rather. And one of their scientists claimed that he found a particle which moves faster than light. Oh, that hits the headlines in every scientific journal because, according to the Einstein theory, nothing can travel faster than light. So everybody jumped at the data and looked at his work and all that. Finally, they found, oh, it is fake claims and data is not trustworthy, all that. So I asked my partner, what happened to your scientist who claimed that something is faster than light? No, he was asked to resign. Okay. That is, I think, one of the characteristics of science. We say, no, what is called a science? Science has self-corrective mechanism. So if we think Newtonian physics is no more applicable, we switched over to relativity of Einstein. And during Einstein's time itself, quantum mechanics came, quantum theory came. Of course, Einstein never accepted quantum. He opposed it tooth and nail. But we know that now quantum theories are also applicable. Okay, now we talk about quantum networks and all that. In future, I think network speeds would be per second, it would be terabytes of, not even gigabytes of transfer. Okay. Anyhow, we know that. So one is objectivity, that whether X does the experiment or Y does the experiment, they should get the result, which is in contrast to religion. If I say that I have seen the God, but I cannot show it to others, so this is not acceptable in science. Then another is self-corrective mechanism. That is, tomorrow, if my view is proved wrong, I have to accept which is the right. But again, that itself may be proved wrong. This is ongoing. Okay, now. Freud, I think probably you might have heard psychoanalysis theories. No, even I read some of his books, especially his interpretation of dreams. And many people say, see, in psychology, medicine, and all this, they won't tell the name of the subject because privacy concern. Even in survey research, for example, you want to do some kind of Delphi method you want to use, and you contacted some experts, but the experts insist, no, don't reveal my name. So anonymization. Okay, anonymization is a common thing in many social sciences and humanities. Okay, so some people say no, because it has to be anonymized to suit his psychoanalysis theories, no, pansexualism. He created his own stories without having any subjects. That is one of the allegations against Sigmund Freud. But in any case, I think Freud was great in removing the shackles of Victorian Europe. I think he liberated psychology, because good old days people used to think mad people were treated as they are possessed by devils. And we know this exorcism and all this came into picture, which was a bit unkind to the subjects. Anyhow, leaving that. Then there was one interesting person, Aaron Swartz. This guy, young fellow from, I think, MIT, if I remember, he started downloading simultaneously from JSTOR. More than JSTOR, the government of US framed a lot of cases against him. It appears he would be sentenced to life imprisonment for downloading. Okay, that means in US life means life. Okay, not some 14 years or something like that, or pardoning for good behavior. Nothing is there. Okay, then the boy was forced to commit suicide. That shows how much the governments are interested in protecting the the interests of the industry. This is a typical case. So this is all because the openness is not there in the society. Okay. Now closed data. Data is not published. That means I have the data, but I did not publish it. And subscription based. That is, unless I pay, I don't get access to the data. Okay. I mean, what I say is all this is I am against having them. Then access to registered users. Okay, they may not take any subscription fee, but still they ask you to get registered for various purposes. Then once you are registered only, you can access the data. Then data is encrypted. Unless I think the decryption algorithms, I mean, key is given, you cannot access the data. Data requires proprietary tool. That means they use the software, and if you want to access the data, you have to buy that software and access the data. That is also closed data. Copyright, licenses, patents, forbidding the usage. That's why I prefer Creative Commons zero license. Anybody can use it, whichever they want. Otherwise, the patents, we hear some now and then some ridiculous stories. Some bloke in US patented haldi, and some fellow says neem. These patents are also sometimes go to ridiculous extents, and the whole, I think, we have the Mickey Mouse law. You heard of that? I am sure some of you might have heard. When Walt Disney Mickey Mouse was going out of copyright, that means anybody can produce a movie, they bribed the American government to extend the number of years of copyright. So that's why it was called the Mickey Mouse law. Then not allowing robots, and some people nowadays captchas they created. Okay, so that also is restriction to the access. Time limited, they say no, certain time you can access. You pay this money, so you can access the journals next 5 years. After that, no more access. Then political, legal, commercial, all these things also come into picture. We know that the Boris Pasternak or Alexander Solzhenitsyn, so there are Salman Rushdie. I am sure some of their works are, I tried to read Alexander Solzhenitsyn in my college days, Gulag Archipelago. It was a bore to read. I think only thing is anti-Russian, so they gave him Nobel Prize. Okay, so these are, of course, I tell you, both sides, government or so-called people protecting the government. If you leave it open, let the people decide whether they accept it or not. Unless you consider people are morons, so some state or government has to tell them what to read and what not to read. In support of open data, data belongs to mankind, and mostly data is generated by public money. You know that R&D of industry, except pharmaceutical, which is the worst research. Okay, pharmaceutical industry, I think worst kind. Mostly it is done by the private institutes, and it is terrible. They say BP you have to take forever. Okay. So everything, many diseases, they say you have to take it forever. I am sure even if they find a cure, they won't introduce. Facts cannot be copyrighted. Then data value will be fully realized if it is widely used. Restrictions will result in anti-creative commons. Open data creates more harmony because it is like, if mankind has the capability of reading others' mind, imagine the situation. Okay, we will accelerate more scientific research. Okay, if data is openly open, others can draw different conclusions, sometimes contradictory. For example, census data, it has multifaceted. Some people may look at the data, what is the literacy, and in India or various districts or various states. Or you say that literacy and the gender relation, okay, whether women are more less literate, so that we can find out what the causes of it. So different facets. Sometimes using the same data, you may draw different conclusions. Okay, it doesn't mean that from the same data, everybody comes out with the same result. Sometimes may, sometimes may not. Data transparency, of course, I told objectivity and self-corrective mechanism. Okay, case history of patients. If clinical data, for example, for cancer, in my hospital, I gave certain course of medicine. If the patient died, I won't tell that because I may lose business. But if I publish that, nobody else would follow the same course. For example, some course of medicines which I gave cured this one. I keep it because I can make more money and claim, okay, if you join my hospital, I can cure. Okay, so open access journals, institutional repositories, all these we think are digital humanities. All these we think will bridge the gap between the digital divide of haves and have-nots. Okay, and we know that if it's a open, okay, one of the biggest success stories of open data is Human Genome Project. You know, the Human Genome Project, they publish the sequences, okay, the entire genetic information. Of course, mathematically, you have to find out the patterns in the, as I told, the patterns are everywhere. In the patterns of the sequences, we can say that whether complexion of a person is this sequence results in. So they modify the genes, or some cancerous cells were generated by some other things. That's why we hope that from Human Genome Project, we may have fantastic results out of it. But again, the genetic technology also has a dangerous side. They say they can combine potato and a dog and create another creature. These are somewhat dangerous researches. Okay, anyhow. So against open data, some people say public money will be used by private organizations. They don't worry about that. Okay, private guys are encouraging. Okay, then privacy concerns. Okay, oh no. Okay, anonymization. There are other mechanisms to mitigate that. Data collected, cured by private organizations should get back their investments. So private fellow says, no, 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 we have invested, but public, because after all it is public money, taxpayers' money, it should be made available. Data was not collected using data was collected using costly equipment, and we have hired a lot of manpower. We cannot make it open. So data should be freely available without restrictions, such as biased copyright laws. Much of the copyright laws, you can take it from me with my 70 years of life. No government makes laws without taking bribes. Okay, that's why there is a famous, of course, he was not a good guy, Bismarck, the German monarch. He says people should not know how sausages and laws are made, because in sausages they put all kind of rati in the beef and pork, and laws are done taking bribes. That's why he says people should not know how laws are made. Okay, some ridiculous patents laws. Okay, the reason is scientists should be taught the philosophy and sociology of science. Otherwise, they become this one. So science is vastly used for defense purpose, that is to kill people, or profit to rob the people. Of course, not without any side good effects. Good side effects. Sometimes bad intentions also result in good side effects. Okay, debatable. Data in wrong hands. For example, on the internet, if I know how to make bomb, how to make biryani, fine. How to make bomb means everybody may make. It's not good. So sometimes pornography stuff. But again, remember, the internet reflects what we are. Okay, mankind has good side and dirty side. The dirty side guys create all these kinds of things. Okay, and terrorism, okay, is there, and governments also, to counter terrorism, they unleash and get into the privacy of the people. Okay, I mean that's why it is. Don't think governments are holy and people are not holy. Okay, all are one. That's why George Orwell, I don't know whether you read, he had 1984, the Big Brother is coming, and he's watching surveillance every movement. But I tell you, not only the communist regimes, every regime wants to control their people, whether it is Chanukya's Arthashastra, which I read, or the modern governments. Now we come to the research data. I think I have some 30 minutes. Good. Now, what is research data? Research data management includes organizing, structuring, storing, data generated. But finally, the purpose is to make it reusable by others. But we call the entire thing as a data life cycle. Okay, that is from generation to reuse, and again generating some more data and reuse. Okay, why RDM increases individual and institutional reputation? Because data can be cited. Just as publications are cited, when I use some data like the Human Genome Project data or some other data, then I can, it increases the credibility and the prestige of the university. Improves the quality of research. So, for example, if I am forced to make the data generated by me public, then I would be a little more careful with my data. Otherwise, no, like I remember in undergrad chemistry, physics laboratory days, no, if we don't get the exact results of some heat or magnetism, we cook up the data, okay, and show the teacher, sir, I got the same result as prescribed with the text. So, but again, in the case of the research, if I am supposed to publish my data, I would be more careful with my experiments and recording the data. Okay, because after all, your data can be validated by others. Then reduces duplication so that somebody else don't have to generate the data with more money and effort. Avoids loss of data. Okay, see, this is the biggest thing, because many people do experiments, collect the data, but they ignore the data. Okay, once I wrote to a few of abroad guys, because I was giving consultancy to ETV guys. So I wanted to build a thesaurus those days. Of course, not ontologies were not popular. Thesaurus of newspaper. Of course, it touches every walk of life. But I approached some 2-3 guys. Oh, that experiment we did about 5 years back, but we don't have any data of that. So loss of data. Then streamlines it your research process. That means it tells at every stage of data cycle, you have to do these with checklists. This you have to fill. So it streamlines your work. Then nowadays, funding agencies, for example, if I apply for a European project, for example, of course, I did 2 projects funded by European Commission. And I was also on the committees to sanction projects and review the projects carried out by them. So these are funding agencies. Wellcome Trust is there, National Science Foundation, or in India, DST, DBT, DIT, all these guys are funding agencies. Okay, but again, in Europe and US, they insist on data management plan. That means if you are funded this project, definitely you are going to generate this data, and do you make the data public? You have to make it. And while at the time of project proposal itself, they have to fill up some columns. What exactly my data management plan, DMPs. Okay, actually, my research students have developed a what I say. Domain agnostic data management plan. That means whether it is sciences or humanities or social sciences, what exactly the data management plan that should be insisted by the funding agencies. Our idea, of course, this was done about 7 years back. Our idea is one day Department of Science and Technology, because this is being followed in Europe, okay, and the US. I thought if our funding agencies like Department of Science and Technology or biotechnology or information technology, I think we may preserve the data better. But still, I think it is not being done. And I try to, with my limited access to these funding agencies, because I stopped asking for funds from the Indian this one. That's why I went abroad. Okay, for various reasons. Anyhow. So data management plan is very, very important. So again, the institute has to put it in place. What exactly the RDM research data management rules. under how institutions deal with the research data. They should have a policy. Actually, we did for UNESCO. You may access the site. It is called GOAP.info. Okay, that is Global Open Access Portal. GOAP.info. What we did is for UN member countries, whether they have policies with regard to open access to information, open source software, open standards, and open e-learning resources, OERs. So we try to web scrap from, I think, of the 190 countries, we managed about 160 countries, whether they have. If they don't have, we develop templates of what policy they should have in place, not only at country level, but academic level and subnational level also we have done that. Okay, you may visit that site. Okay, then institutions take on RDM to establish policy and strategy. Without policy, I think things would not move. You know that, for example, you take DSpace digital repository software, and many of the librarians out of interest they created. That is bottom-up approach. But again, for example, you take thesis and dissertations of Shodh Ganga of UGC. When UGC mandated it, they have about now 5 million records, almost 5 million records. So sometimes top-down also works. Okay. It ensures that researchers are aware of what data is available. Because otherwise, researchers are bothered more about their research. Their librarians should come into picture and preserve the data they generated. Okay, provide easy to use robust storage of data storage. Make it easier for find and cite. So citation, data citation are not citation data. Data citation is also important. Okay, so DMP, this is what we have done, is a formal document that outlines how data are to be handled. Okay, a requirement by many funding agencies, though not in India, but abroad, because we applied for Wellcome Trust and European projects. Comply with legal and ethical guidelines. Nowadays, everybody in the projects, they add ethical guidelines. That means you are not with your research harming the people. For example, good old days, some of the American psychologists tried to prove that blacks have lesser IQ than whites. Okay, but again, this is unethical actually. Okay, but again, there are some progressive psychologists. They proud that urban whites have the urban blacks have better IQ than rural whites. So that, but again, if you ask me, I consider IQ is bogus. I don't agree with it because I participated in IQ experiments and I saw, I have the first-hand information. There is nothing called IQ. Okay, you cannot measure it. That is, I always feel some of the pitfalls of science statisticians is they think that everything is measurable, which is not the case. There are many things in life that cannot be measured. How good you are. I mean, first definition of good is the first problem comes. Even if you say, okay, charity is good, can you measure the charity? A poor man giving, I think, what he can afford, and a rich man may give in billions. But can you compare? Yes. So you cannot quantify just by money. Oh, he gave billion, this poor fellow gave only 10 rupees as a charity. So, I mean, I feel the one of the pitfalls of statistics and science is they think everything can be measured. Okay, the things that can be measured can be objective, but we know that human relations, everything, a lot of things are not quantifiable. Okay. Okay. Then policy should be the guide. Government should mandate. Okay. For example, in India, we have NDSAP, that is National Data Sharing Accessible Policy. It was done by, I think, Prime Minister's Scientific Advisory Office some way back in 2012. Okay, I reserve my comments on that. Then funding agencies, DMP, okay, organizations, research labs, and universities. At a university level also, we should have data plan, management plan, DMP. Evolve policy in tune with the government and funding agency, or digital curation centers. Many people started in UK and the US digital curation centers, and librarians should be trained. This is, I think, the crux of the problem. I know that way back after 2012, even defense laboratories got circular from the government. You identify the data that doesn't require classification. It's not classified, but you publish on datagov.in. But finally, I find in datagov.in, first thing is it is badly designed because we have better idea of data than some guys who built it. I know who built it, but I don't want to name it rather. And also, the only agricultural guys were more active than other sectors. The reason could be, first thing is the heads of many organizations are not aware of what is open data and what is government mandate. And another thing is librarians are not trained. So one of my dreams is to run training workshops to the library community on data curation, how to curate the data and how to publish the data, just as we did for DSpace. I think all the librarians became active and conducted a lot of practical programs, workshops on DSpace. And I think we are one of the top countries in the world having digital repositories. Okay, the what kind of publications available, those things are secondary, but the enthusiasm definitely it reflects. Our library community in India is very, very active. Okay, now so is the case with one day I am sure down 4 or 5 years we may have more data repositories. Recently in FlipNet, I was chairing a committee to frame a policy for data. Okay, some national data repository policy. If UGC and others, they accept it and make it, probably once they mandate it. For example, NAC, if you say unless they have a data repository, they lose some score. Then people become active. Okay. So that's why I think if the policy framework we designed was acceptable to UGC, then I think things move much faster than expected. So research data life cycle, we capture, that is collect data from surveys, experiments, equipment from this one, structuring the data, database tables, formatting using open standards, and cataloging, that is creating metadata, okay, and assigning subject descriptors. And one of the important things is linked open data. That is, for example, you have agricultural data of say various states, but I want whether I can combine the agricultural data published by various states on their respective sites, whether I can aggregate and show the results. And that for that, now think many people say LOD, that is linked open data, is very popular. In fact, this is one of the prescriptions of Tim Berners-Lee, who created web and semantic web also. One of the 5-star data, he says, it should have linked open data. Then persistent identifiers. So that is, of course, very, very important. Now, persistent identifiers have become very, very popular. Okay. Then data repository, making data discoverable, shareable, and allowing harvesting and reusability of the data. Okay, so RDM includes, briefly, okay, creating and acquiring data. Of course, domain experts create the data. We acquire and anonymize the data in cases of clinical and psychology, these experiments. Converting the data into open standards, adding metadata, classifying the data ontologies, adding licenses, adding persistent identifiers, host of data, hosting, yes, T is missing, and backup. And a few examples of research data, we know that maps, genome data, chemical compounds, biomedical data, government data, GIS, that is the geographical information systems, weather data, simulation, log data, okay, social media data, and surveys. Fair data, everybody nowadays, instead of using 5-star data of Tim Berners-Lee, this became popular in Research Data Alliance, RDA. There is a worldwide voluntary organization where scientists and librarians, everybody gather And they say that fair data means the data should be findable, accessible, and interoperable and reusable. Okay, if it is interoperable, then of course it ensures reusability. This is what Tim Berners-Lee, he gives the starring for each aspect. The data is available under open license, 1 star. This is a structured data, 2 stars. And non-proprietary open format, that is, it followed open standards. Okay, use URIs, that is persistent IDs, 4 stars. Linked open data, 5 stars. And data librarian, providing access to data. I think I have another 14 minutes. Okay, no, I will try to have some 10 minutes for the question answers. And providing access to data. These are all actually, if you look, no, okay, that nothing is new. Instead of handling in books and information, now we are going to handle data. Okay, awareness and support for managing data, because at times I feel librarians are more aware of the developments in data or information than the heads of the organizations. Managing data collection, that is curation and other things. Core competencies, some level of subject knowledge. Professor Bhattacharya used to say, we need not know the subject, we should know about the subject. So the about knowledge, what we are, okay, and how to provide access to data centers, repositories, then policy and standards for RDM, then data management tools, what are the tools for that, then metadata schema, that is the data formats, domain ontologies, and all that are some of the competencies required by a data librarian. So linked open data, you should know, data repositories, data citation, research practices, and workflow. Okay, and points to point, what we realized with our experiments in DRTC is there is no one specific metadata schema. Though we consider Dublin core serves as the lowest common denominator, but to describe, we require some domain-specific descriptors. So no one size fits all. Are there common collection? Okay, what are the data-intensive domains? Some domains generate a lot of data. Okay, file formats, open versus proprietary. For interoperability, you require open. Then compressed and uncompressed. Sometimes we have to force compression because of the amount of data is very large. Then open lossless formats, RTF, XML, uncompressed TIFF, like that. These are some of the metadata schema like Dublin core, Darwin core, so many are there. VRA core for images, like that. Then ontologies, I explained already. We use the SCAS is simpler. OWL is somewhat complex. Anyhow, leaving that. Then some licenses. There are many licenses, but I prefer Creative Commons 0, which I have put the label on the front page. Data citation. Okay, just as an article is being cited, whenever you borrow data from some other site, we have to give citation. But again, this is again not an alien knowledge. Some like you have title, author, other things. Okay, it helps linking the data because linked open data is important. See, you can see that there is no big deal in this data citation. Author, principal investigator, maybe ORCID, his persistent ID, title of the data set, version number, probably, census data and all that. Let's say there is an increase in the many columns. And file formats, location of the data, URI, place of publication, year of publication. So nothing is alien to us or strange. So data validation software, we used open refine extensively, but you have modules in R, which I advocated, or you can write some Python programs. It also has some modules to handle data curation. And there are many commercial tools. Software, we experimented with Dataverse and CCAN. Though people say that CCAN is mostly for government data, Dataverse is for scientific data, we did not find, I think data is data. There is nothing big deal about it. And CCAN has many plugins on GitHub. For some time, I created an ISO live CD for CCAN. Dataverse percentile of development activity is very less. And there is a registry like Open Door. We have open door for the open access data repositories. It is called re3data.org, where people, whenever they created a data site, a data repository, they register themselves. But be careful, many of them are ordinary DSpace repositories, but they wrongly entered. And unfortunately, RE3 guys did not curate. What is not a data repository, they should remove. And there are search sites. Google has a data set. If you want to retrieve data, there is a search called datasearch.research.google.com, and Elsevier also has a search site. And in DRTC, of course, we conducted many things related to it. One is European Commission project, agricultural data. We were involved with UNFAO, Chinese Academy of Agricultural Sciences, and others. And we conducted with CoData 2 workshops, okay, on at an international level, okay, and we had an international conference also on big data and knowledge recovery. So conclusion is, biggest consumers of big data are internet are business community and governments. Privacy security issues are at stake. Many technological inventions have a flip side. Actually, technology is neutral. How the people or politicians or government, whether they use or misuse is the question. Okay. This is, I think, what we advocate. I always say open source software access and all that. And thank you. And if you have any questions, I think we have just another 10 minutes. I'll be more than happy to answer your queries.
Hello, dear participants. If you have any queries, just
I thought I left very little time for queries. It appears more than the.
no issue there. It's the right time. It's the right time.
Just I am joking. It appears if nobody responds, I think I could have explained things a little more. And
Right.
I hurriedly skipped some of the slides without elaborating the content.
Anybody having any query, please?
Or you can put it in the chat box also.
You can put in chat box also. No issue.
I have a question.
Yeah, please.
Sir, you had shown a note in your slide that we developed an online model to be adopted by Indian funding agencies.
DMP online.
So please.
I
Yes,
can,
sir.
okay, immediately I don't, it was published in IPM, Information Processing and Management. I will pass on the exact, the reference to Professor Raza, and probably he may circulate it to you.
Okay.
It was published, I think, some 3 years back. Okay, 3 or 4 years back.
Sir, please provide.
I know that in a prestigious journal, IPM, they got it published. Okay. I'm sorry, immediately I may not be, but because I was involved in that, though I am not one of the authors, because I always tell people, hey, I am about to retire, why do you put my name? It's of no use anybody. So, but any case, what it tells is, it is neutral to any science, whether it is natural or physical or social sciences, or but again, okay, the way it was designed is, if you answer you are a social scientist, it removes some of the questions, okay, which are irrelevant to social sciences, okay, only relevant to physical or natural sciences. And so depending on the first few questions you answered, rest of the questions are generated. We believe that what they did is, they compared many DMPs, data management plans, insisted by many funding agencies like Wellcome Trust or NSF or European Union or Australian government, all this. And we try to get the best out of everything.
Thank
Is
you,
that
sir.
fine?
Thank you so much. Yes, sir.
Any other question?
Sir, good afternoon, sir. Sir, good afternoon,
Yes,
sir.
please.
You pointed about the data repository software, data versus CCAN, DKN, tried. So you give more information about that, sir. How we repository our data.
Okay. What they do is, of course, immediately what you can do is you can access data.gov.in. Okay. That is Indian government's data. But I think in our survey, we try to compare by the repositories by various people. We found Australian government data is much better than even American this one. Okay. So what we do is like these space, we try to organize the data by institution and by under that by subject, and they upload the data. Okay, especially CCAN allows even graph generation of the data set. Say, for example, you are interested in some data. Before you want to use it, you want to have a visual appearance of the data. Okay, so CCAN has many features, and they follow actually Dataverse follows another cataloging schema called DCAT. That is data cataloging. That is a metadata schema, but CCAN keeps it open. Key values, so you can enter anything. Okay, that is you can customize your own. So like that, I think though actually we invited Dataverse people also, we found the development team is very small and percentile activity also slow. Though some people believe no, Dataverse is suitable for research data, but I did not find any justification for that kind of a claim. So we used extensively CCAN. Some people created a Drupal interface to CCAN, which they call it DCAN. Okay. So you have to upload the data, whether it is in tabular data or images or videos and other things, and people can download. Okay. And of course, DCAN, one advantage with CCAN is on GitHub. No, if you go to github.com, it has lots and about 100 plugins are there, which I feel, okay, the percentile activity is quite high. So that's why we preferred, even it tells whether the data is 5-star compliant. Okay. And some are ready-made plugins are also there, which was mentioned, say Australian CCAN. So you don't have to customize. If you want to follow the entire, the way the Australians did, you just use that. You don't have to customize at all. Okay. And it had so many plugins. Okay. So my personal choice is CCAN. Though I tried to convince the InflameNet people because they were more convinced with Dataverse. But I was trying to convince them. I think we both are, we stuck to our guns. Okay.
Thank you, sir. Thank you.
Thank you. Thank you.
Any query further? I think your lecture was comprehensive enough, so they have received well.
Sir,
No, but
if you
again, what I request my library community people is
Right.
keep your eyes open.
Open, right,
And
right.
we are highly sensitive to the developments in the technology side. And I tell you, digital libraries worldwide are more promoted, or initiatives were done by library community rather than the scientific community. So sometimes on these things, I am proud of my own community, and we do well. Okay, that is my whatever. So if you become active, I think soon, my dream, I think for a long time, is to organize workshops on data repositories. Hope someday it will happen. Okay. Yeah.
sorry to interrupt you, sir. Can I ask another one question, sir? Is it, if it is possible?
Absolutely.
Sir,
As
you
long
and
as
you and Professor Ramesa sir clearly explained about the data. What are the ways we collect the data? What are the data we collected? Our college is a government college. We have central library and 15 department libraries. we are collecting data from the department libraries and central library. All are put in the Excel format only. Is it possible to store any other repository? We are collecting
No.
user study.
Excel is good. Actually, nowadays, Excel became a common this one. For example, in DSpace 7 onwards, if you want to dump your Excel data into DSpace, either importing or exporting is possible, or even some of the library automation packages, they allow Excel data to be uploaded into their main databases, which is mark based. I think that is fine. Okay. Maybe you can write to InfluentNet guys. I think they developed some tools. I did some, for example, old CDSIs to DSpace like that. I wrote some programs and distributed. But I hardly work.
They developed. They developed
they might have
e-Grantha.
Yeah,
e-Granthalaya.
they might be having. Otherwise, ask them. You develop something. I have Excel data. How to ingest the same data into the e-Granthalaya. I think they do that. Though
Thank
I
you,
am
sir.
not quite familiar with library management software, because I thought, okay, I never worked. Librarians know nuances or nitty-gritties of library management software. Okay, better. But some people approach me, can you evaluate? I say, you approach any librarian, they would be better than me. They can give better inputs than me. Because I know my limitations. Okay. Okay.
Thank you, sir. More than 15 years I know about yourself, ARD Prasad, sir. But this is a time to I see
Okay.
directly and learn more information from you, sir. Thank you for the coordinator
Thank you.
and director of MMTCA, Aligarh Muslim University, sir.
Yes.
Thank you.
Thank you. Thank you from my side.
Okay, I think no further queries, sir. They all are satisfied. And let me thank on behalf of department, on behalf of SRTC, on behalf of participants. I'm really thankful to you, sir, for sparing time and just engaging, giving a very engaging lecture and thought-provoking also for everyone. So I think participants also, they are very happy. And if there is any further query, I'll just pass on Professor Prasad's mail. So you can,
Yeah, you can write to me.
if there is any query or anything is there that you want to discuss further, that you can contact him on mail.
Yes.
Will that be fine? Will that be fine? I think.
Yes, sir.
Huh?
Yes.
Yes, sir. Yes, sir.
So thank you once again. Thank you
Yes,
once
sir.
again, sir.
Thank you, Professor
Thank you
Raza.
once again.
And
Thank
also
you.
I thank
Thank you, sir.
AMU for this.
Thank you, sir. Thank you once again.
Have a good day and have a good career. Okay. Thank you all.
Thank you.
Bye.
Thank you.
Thank you, sir. Sir, thank you.
Thank you.
Thank you, sir.
Mazhar,
Thank you, sir.
Mazhar, if you are listening, just close the meeting.
Thank you, sir.